let's go over the properties of real numbers. And these are things that you can and can't do with certain operations. They work for some, but not the others. So let's actually, in a sense, discover that. Which operations does, well, we'll start here with the commutative property. Which operations does the commutative property work for? So the commutative property, real quick, is if you can switch the order of the A and the B around a certain operation and the answer is the same, then that operation is commutative. Now, here, this asterisk is just a general symbol, meaning any operation, but we're going to try this with addition, we're going to try this with division, and let's see which ones they work for. So, first up is addition. First up is addition here. What is 7 plus 4? Well, 7 plus 4 is 11. Okay, cool. What about 4 plus 7? What's that? Well, that is also 11, right? So is addition commutative? Yes. It didn't matter if we did 4 plus 7 or 7 plus 4, A plus B or B plus A, right? The answer was the same. Therefore, this operation, addition, is commutative. Let's try this with subtraction. 12 minus 3. What is 12 minus 3? 12 minus 3 is 9. What about 3 minus 12? What is 3 minus 12? 3 minus 12, well, that's negative 9, right? Close, but not exactly, right? That is a different number. So is subtraction commutative? No. If you reverse the order of subtraction, you get a different answer, specifically the negative of the previous answer, right? So reversing subtraction negates the answer. It is not commutative. What about multiplication? Let's see right here. What is 4 times 6? Well, I should say it in order, right? Here, this is 6 times 4. Could be different. We're trying to find out. What is 6 times 4? Well, that's 24. What about 4 times 6? What about 4 times 6? Well, that is also going to be 24, right? So is multiplication commutative? Yes, right? Multiplication, the order does not matter, right? 6 times 4 is the same thing as 4 times 6. A times B is the same thing as B times A. What about division? What about division here? We have 10 divided by 5. 10 divided by 5 is 2. All right, what about 5 divided by 10? If you're not sure how to deal with this, just write it as a fraction, 5 over 10, 5 divided by 10, and this reduces to 1/2. Now, are 2 and 1/2 the same thing? Nope, they are not. They are related, but they are not the same. So, is division commutative? No. If we switch the order of division, it will change the answer. Subtraction negated the answer. Division reciprocated the answer. So that's a little extra if you want to ponder that. Okay, good. So this is why you may have heard of the commutative property of addition and the commutative property of multiplication, but you'll never hear of the commutative property of subtraction or division because neither of those operations are commutative. This brings us to the associative property, which means if we'll just do 3 numbers, if you're dealing with 3 numbers here, it doesn't matter how you group them. You could do the A and the B first and then the C, or you could do the B and the C first and then the A. Now, again, this asterisk, I know it might be a little weird, but it's just a general operator here. You could put plus signs through there, and that would be the associative property of addition. You could put subtraction signs through there. Well, let's even see if that works, right? But anyways, let's do addition first. So say that I want to add up 5, 7, and 13. But let's do the 5 and the 7 first. So 5 plus 7, well, that's 12. And then we add that to 13, and that's going to give us 25. All right, so the answer there is 25. But what if, instead of doing the 5 and the 7 first, we did the 7 and the 13 first? Well, 7 plus 13 is 20, and 5 plus 20 is 25. So sure enough, right, we have the same answer. It didn't matter which 2 numbers we added first. So is addition associative? Yes, it worked for addition. Let's try subtraction. So over here, we want to subtract 11, 4, and 3, but let's do 11 and 4 first. 11 minus 4 is 7, and minus 3 is 4. All right. But what if instead we did 4 minus 3 first? Well, that would be 11 minus 1, and 11 minus 1 is 10. We have different answers here, right? So changing the grouping of subtraction did change the answer. So is subtraction associative? No, it is not. Multiplication here, let's do first, we'll do 5 times 3, which is 15, and then we'll multiply that by 2, which gives us 30. But what if we do 3 times 2 first? Well, that would be 6, and 5 times 6 is also 30. So is multiplication associative? Yes, multiplication is associative. Division, we want to divide 20, 10, and 2, but let's do 20 divided by 10 first, and that is 2. Divided by 2 is 1. But what if we did 10 divided by 2 first? Well, that would be 20 divided by 5, which is 4, and these are different answers, right? So changing the grouping of division does change the answer, so division is not associative. So again, this is why you may have heard of the associative property of addition and multiplication, but there's no such thing as the associative property of subtraction or division. It does not work for subtraction and division. So those are the winners. All right, let's put them into practice here. So here's some practice problems. You can pause this and try these on your own. I recommend you do so, but I'm going to go through them. Use the commutative and associative properties of addition, specifically addition here, okay, to evaluate the following. Good. This is a good example of, well, these are good examples of you don't have to do it this way, but we're going to do it this way. You have options and you can choose what you want, right? So I could just solve this problem using PEMDAS, do the parentheses first and then add 2 afterwards, but you could, if you wanted, you could use the associative property. And why might that be desirable here, right? These problems are designed so that if you apply the property, it becomes a little bit easier. Well, maybe 34 plus 18 isn't something that comes to you real quick. That's okay. We could change this using the associative property and put the parentheses around the 18 plus 2 instead. Well, what's 18 plus 2? That might be a little bit easier to come by, and that is 20, and 34 plus 20 is 54. Did you have to do it that way? No. Could you do it that way? Yeah, sure. Either way, you should get 54. Let's do the next one here. Now, as it's written, we need to add 3/4 and 2/5, and then whatever that is, we're going to add 3/5 to it. But if we wanted to, we could apply the associative property and move the parentheses around the 2/5 and the 3/5. Now, why might that be desirable here? Well, because the 2/5 and the 3/5 already have a common denominator. You don't need to go searching for that least common denominator. So this would be 3/4 plus 5/5, which is really just 1. But, I mean, either way, I guess this problem isn't good for making an argument in favor of the associative property because you're going to have to find a common denominator anyways. And yes, I know half of you right now are thinking that 5 divided by 5 is 1. You know what? Why not? 1. We still need a common denominator, though, and that's going to be 4. 1 is 4 out of 4, and so the answer is 7 out of 4. If I lost, wow, 3, okay, 7 out of 4. If I lost you there, I apologize. You may need to remind yourself how to add fractions, but the point of this example is that if you don't want to add these two fractions first because they have different denominators, you can actually add these two fractions first because they do have the same denominators, and that is putting to use the associative property. Good. All right, here we go. Here, let's apply the commutative property, which means I can swap the order of addition. So this whole 17y plus 13, if I wanted to, and we do, I can make this 13 plus 17y. And why is this desirable? Well, because if you didn't see it before, maybe you now see that those will just cancel out. And the answer is 13. Again, I know 17 plus 5 is not that big of a deal, but if that's got you stumped, you could go ahead and do 5 plus 25 first. And I like my 5s, right? Counting by 5s generally is a little bit easier. This is 30, and then 17 plus 30 is 47. So again, you don't have to do that, but you can. right? You can apply the associative property. This is the same. We already pretty much did this. Because 8 and 13 are not common, we could change the grouping here and do the fractions that do have a common denominator first. Literally the same exact problem. It becomes 13 over 13, right? 7 plus 6 is 13. 7 plus 6 is 13. 13 divided by 13 is 1, but we are dealing with a fraction out of 8. So we're going to rewrite that 1 as an 8 out of 8. Let me pause here real quick. I know this is going fast. 8 divided by 8 is 1. Those are the same value. So I can replace 1 with 8 over 8 if it helps me out. And it does, because we have this 3 8s, right? We have to make those match. And 3 plus 8 is 11. The answer here is 11 eighths. So if you want, here I am going to stand by using the associative property. It feels a little bit forced, but I would argue that the way we just did it would be easier than trying to find a least common denominator of 8 and 13. In fact, I do not know what the LCD of 8 and 13 is. I think you should do it this way. It's a pretty good way to do it. Use the associative property. Here, this is identical to the example above it. If we apply the commutative property, we can write this as 99 plus 25a minus 25a, and then those will cancel, leaving us with an answer of 99. So again, you can move things around. You know what? Pause. I want to teach something here, something that came to me recently, and that would be, what if I was dealing with something like, well, let's just go 10 minus 7. Now, as we saw in the beginning of the video, this is not the same thing as 7 minus 10, right? You cannot use the commutative property with subtraction. However, there is a way we could force the commutative property into this. We just have to rewrite it as addition. So 10 minus 7, whereas it's not the same thing as 7 minus 10, it is the same thing as 10. It is the same thing as 10 plus negative 7. And now what you have here is you really have addition. And that's commutative. So we could rewrite this. We could use the commutative property, swap this around so that it's negative 7 plus 10, which is negative 3. And again, yeah, so whereas 10 minus 7 is not 7 minus 10, 10 minus 7 is the same thing as negative 7 plus 10. Now, you may think that I'm just making this more complicated than it needs to be, but hey, the more you know, the more tricks you have, the more problems you'll be able to solve. So that is a way you can handle that. There is no commutative or associative property of subtraction, but if you rewrite it as addition, then you can apply those properties. Anyways, multiplying fractions and integers. Okay, so I'm pausing here. I'm going off on a tangent a little bit because this is going to be applicable in the next page, on the next page, but I do want to show you how to multiply integers to fractions. I like to say multiply up, divide down. Multiply up, divide down. Now, it actually doesn't matter what order you do this in. In fact, I recommend that you divide down before you multiply up if possible, because, right here, 12 times 7, you may or may not know that, it's a little bit undesirable. 12 divided by 4, not as bad. So let's do that. What is 12 divided by 4? What is 12 divided by 4? Well, 12 divided by 4 is 3, and then we need to multiply up. We need to multiply that to the 7 up top, and 3 times 7 is 21. That is the answer there. 7/4 of 12 is 21. Let me zoom out here and give you the freedom to pause and try these out if you want. Here comes the next one. Multiply up and divide down. Here we can divide down. 15 divided by 3 is 5, times 2 is 10. The answer is 10. Even if there's a variable involved. divide down and multiply up. 22 divided by 11 is 2 times 12z is 24z. You could almost ignore the z, it just goes on for the ride. It goes along for the ride, but the math is still the same. Even if the fraction comes first, it's still the same thing, right? That's the commutative property of multiplication. It doesn't matter if you put the integer before the fraction or the fraction before the integer. We need to multiply up and divide down. But here we go. Now we're starting to see some variety here in that, can we divide down first? Is 9 divisible by 5? No, it is not. So you're just stuck with multiplying up. 9 times 2 is 18. Just tag on the a and leave that over 5. And that's it. Not very exciting. There's not anything else you can do there. Multiply up, divide down. Check the division first. Can we divide 5 by 4? No. So all you have to do is multiply 5 times 3, which is 15. Tag on the b and leave that over 4. Last one, multiply up, divide down. Is 3 divisible by 13? No, it is not. So we're just left to multiply 3 by 6, and that is 18 over 13. This brings us to the distributive property, and you'll see why I had you multiplying fractions and integers on the previous page. That's going to become applicable here. The distributive property, we're not going to check which operations this works for. I'll just tell you, it's a combination of addition and subtraction. If you're multiplying by some parentheses that have addition on the inside, we can just multiply into each individual term, and you'll get AB plus AC, right? That's the distributive property. You've seen this before. Let me show you how it works. So, meaning here, right, can we add 2a and 3? No, but what we can do is we can distribute this 5 into the parentheses. So 5 times 2 is 10, tag on the a, and 5 times 3 is 15. There we go. Okay. That's it. Not very exciting on that one. Next one here, let's distribute a fraction. So here we go. Same rules apply, same rules apply. This is why we just did what we did on the previous page. I need to multiply the 2/3 by the 6x minus, and then I need to multiply the 2/3 by the 9 as well. And each of these can be dealt with by multiplying up and dividing down. Multiply up, divide down. Let's start here. Is 6 divisible by 3? Yes, 6 is divisible by 3. What is 6 divided by 3? Well, 6 divided by 3 is 2. So pause. I'm trying to color code this. This 2 is that 2, right? But this 2x is from 6x divided by 3. Minus. I'm going to copy down the 2. And what is 9 divided by 3? 9 divided by 3 is 3. All right. And then now we just multiply. 2 times 2x is 4x. And 2 times 3 is 6. And that right there is the answer. This is a good problem right here. Careful, we're not distributing the 10. The 10 is its own piece, right? We only care about what's right up against the parentheses. Well, what's right up against the parentheses is the 3. Well, technically, a -3. That 3 is a -3. And when we distribute it, we need to keep that in mind. So I will write this in 2 steps just to make the point. So this is going to be 10 minus 3z. And then careful here, technically this is -3 times +5. And -3 times +5 is -15. So we put -15, right? Good. Now we combine like terms. I'm going to stick with the feeling of this lesson. And this, you may feel like I might overcomplicate this, but let's see, how would I do this? I'm going to rewrite this as 10 plus negative 3z plus negative 15. And this is overkill. This is overkill. But what I want to do here is I'm going to force in the commutative property of addition, which means I can swap this. This is now addition. And I can swap that. A plus B is the same thing as B plus A. So this becomes 10 plus negative 15 plus negative 3. Wow. I can't draw threes. Here we go. And this becomes 10 minus 15 minus 3z. Now, this was a super extra way of just getting the 10 and the negative 15 together. If you saw that from the beginning, that's fine. You don't have to do all this. But I want the 10 and the 15 together because I can subtract them. 10 minus 15 is negative 5. And then we just bring down the negative 3z. Maybe you had negative 3z minus 5. Those are both correct. These steps are not necessary, but that is a detailed description of what really goes on in this problem. Did I zoom out at all? I don't think I did. So let me just show that. You can try some of these on your own. I'll walk you through them. Distribute the 7. 7 times 3 is 21, and 7 times 2 is 14. That's it. That's the answer. Another one with a fraction. I'm going to distribute the fraction. Distribute. And let's color code this. Keep track of everything. So I need to multiply the 5 halves times the 7b. And I need to multiply the 5 halves as well to the 3. All right. Well, let's check here. Can we divide down? Is 7 divisible by 2? No, it is not. So we need to multiply 7 by 5. 7 by 5 is 35. Just tag on the b and leave it over 2. Plus, is 3 divisible by 2? No, so we have to multiply 3 by 5, which is 15. Leave it over 2. And we can't combine these fractions in the sense that, right, only one of the numerators has a b. But we can combine them in that they do have the same denominator. So we can write our final answer as a single fraction, but the numerator is not going to get any smaller. 35b plus 15. 35b plus 15. That one did not divide. Here we go. This is just like the one above it. I'm going to do this one fast. 22 minus 5c minus 20. It does become minus 20. Let's fix that c. Right? Because negative 5 times positive 4 is negative 20. Right? Pay attention to the signs here. And then we could just go ahead and skip across and do the 22 minus 20, which is 2. Tag on the minus 5c. If you also wrote negative 5c plus 2, that is technically correct. It's just a matter of preference. Down here, if we distribute the s, we have st minus 4s is the answer, just like that. Over here, we're distributing the 8, so the setup here is going to be 8 times 5/8k plus 8 times 3/4. So let's check. Can we divide down? Yes. In fact, those 8s will just straight up cancel out. 8 divided by 8 is 1, leaving us with a 5k plus. All right, here we go. I'm doing this in one step. What is 8 divided by 4? 8 divided by 4 is 2, and then we need to multiply that by 3. 2 times 3 is 6, and that is the answer. Oh, this is a good one. This is just straight up called distributing the negative. So I need to distribute the negative. Yes, technically there is a -1 there. I'm just going to call it distributing the negative, meaning everything in the parentheses after that negative needs to change signs. Whatever's positive becomes negative, and whatever's negative becomes positive. This does not affect the 7p minus 3. Those come before, but then this will change to minus p plus 5. Plus 5. And then we can rearrange here to put our terms together. Some of you may be thinking, hold up, he just switched around subtraction, but I thought there was no commutative property of subtraction. If you thought that, I want you to think a little bit harder about this. I did not. I technically did not. And you can find explanation of that in this video. 7p minus p is 6p, and then -3 plus 5 is positive 2. So 6p plus 2 is the answer. Subtraction property. So I've already hinted at this in the video, but let's get it out here explicitly. Subtraction is the addition of a negative term. So this is how you switch between subtraction and addition. Technically, subtraction is, yeah, again, the addition of a negative term. So this whole 15 plus -3a, that is the same thing as 15 minus 3a and then minus 7a. Those mean the same thing. 15 minus 3 is 12, minus 7 is 5a. The a just tags on for the ride. Didn't really do much there. Same thing here. All this plus a negative really just means minus. This is 30x minus 12x minus 6x. 30 minus 12 is 18, minus 6 is 12. The x just goes along for the ride. Okay, what point am I trying to make with this problem? I don't really know. What is -16 plus 4? -16 plus 4 is -12. Plus 5 is -7y. So there you go. All right. Let's go to the identity now. So if a times or a plus or a minus whatever, a operate x is a, then x is known as the identity operator, meaning it didn't change the problem at all. So what is that for addition? What is the additive identity? What do I need to add to 7 so that it remains a 7? Or what do I need to add to 23 so that it remains a 23? And the answer there, of course, is 0. 0 is the additive identity. Adding 0 won't change a thing. But what about multiplication? What do I need to multiply by -6 so that it stays a -6, or by a 2 so that it remains a 2? And the answer there is 1. Multiplying by 1 doesn't change a thing, therefore 1 is the multiplicative identity. 0 for addition, 1 for multiplication. Building off of this, we have the inverse property, which means if I multiply or add or whatever two numbers, and I get x, where x is the identity operator, then B is known as the inverse operator. So, sorry, that might sound like a bunch of nonsense to you. Let's just do it and you'll see it. What do I need to add to 5 to get 0? What do I add to 5 to make 0? Well, that would be a -5. What would I need to add to 2, to -2, to make it a 0? And that would be a +2. So essentially the opposite, right? That is called the opposite. Thus, the additive identity of A is -A. It's the opposite of A. Did I say identity? That's the additive inverse, right? No, look at that. That's a typo right there. Well, we're too far into this video. I am not starting over. So that should have said the additive inverse. There we go. I got it right on this side. What do I need to multiply by 14 to make it a 1? 1 being the multiplicative identity. I'll let you think about that. What about over here? What would I multiply by a half to make it a 1? Well, this one might be a little more understanding. Here we go. That would be 2. 2 times a half is 1. What about 14? Well, that would be 1 over 14. That would be 1 over 14. Therefore, the multiplicative identity of A is 1 over A. And there's a word for that. That is called the reciprocal, right? So the additive inverse will be the opposite, but the multiplicative inverse will be the reciprocal, right? So that's the relationship there. Properties of 0. Let's evaluate the following. What is negative 5 times 0? Well, it's just 0. Well, what if the 0 comes first? What if it's 0 times 77? Well, that's also 0, right? If I'm multiplying two numbers and one of those numbers is 0, it doesn't matter which one comes first, the answer will be 0. Same is true in division as long as I believe it's called the dividend, let's call the numerator, is 0. 0 divided by anything is 0, but if 0 is the denominator or the divisor, that is, I'm not even going to put an equal sign. That is undefined. You actually can't divide by 0. Funny things happen when you try to divide by 0. If you've ever touched calculus, you may have heard of the derivative. The definition of the derivative, in a sense, is trying to divide by 0. It's wild. You use something else called a limit, but don't worry about that. That is way beyond this. Multiplication with decimals. So let's just multiply these. I don't remember why I put this here, but hey, the more you know. Well, I get it. It's related to the associative property of multiplication here in that you could either multiply the first two numbers first if you wanted, or you can multiply the second two numbers first. It doesn't matter the grouping because this is multiplication. And I will argue that you want to do the second two numbers here, right? 0.5 of 4, that's saying half of 4. What is half of 4? Well, half of 4 is 2, so really we're just multiplying 11 and 2, which is 22. That's a little bit more desirable than trying to multiply 11 by a half, because 11 is not divisible by 2, and that would not eliminate the decimal. Notice how there are no more decimals left in the second step. That is because we chose to multiply those two numbers first. Going over here, 100 times 0.07, I don't know how to explain it other than, well, yeah, you move the decimal over 2 places, and because you're multiplying by 100, and this is 7y. This is 7y. What about right here? Yeah, again, let's think about that associative property of multiplication. Is it more desirable to multiply 9 times 0.25 or 12 by 0.25? And if you are aware, 0.25 is 1/4. 9 is not divisible by 4, but 12 is. So I would say it is more desirable to group it here and do 0.25 times 12. What is a fourth of 12? A fourth of 12 is 3, and 9 times 3 is 27. And here we go. 1,000 has 3 zeros, meaning when we multiply by 1,000, we move the decimal place 3 places to the right. So the answer here is just 4x. And is that it? Yeah, that concludes this lesson. Thank you for sticking around. Hope this helped. We'll see you in the next one.